Hi guys, Ms. Raymond here, and today we're going to review how to do pvtn problems. This is from the packet that you got on Wednesday, October 16th. So if you were here, you'll be able to follow along with what you've already gotten done. If you were not here, then you can fill it in as we're going and make sure that you pause and rewind if you're not understanding something. Okay, so let's start. We're going to start with question 2. So question 2 says that we have a bicycle tire, and this bicycle tire is at 105 psi. So you want to think about what that 105 psi is. That 105 psi is the initial pressure, because we know that psi is the unit for pressure. Then it tells us that it's at 25 degrees Celsius. Well, 25 degrees Celsius is temp, but we have to remember that we want to add 273 so that we get Kelvin, and that gives us 298 Kelvin. And that's because all of our gases, any gas equation that we use, we have to use Kelvin temperature and not Celsius. Just like what we did in the lab, we saw that we didn't get a 0 point on our graphs with Celsius, but we do with our Kelvin. Okay, if we keep going, we see that it says you take the bicycle up to Huntington where the temperature is -5. Again, add 273, and this time we get 268 Kelvin. So that means that the final temp is 268 Kelvin. Now, it wants to know what is the pressure in the tire, so that's our question mark here. It also tells us that V and N are constant. So if V and N are constant, that means that we can actually just kind of cross them out. Now, our last step that we're going to do is we have to look at this and we have to think to ourselves, okay, well, what's actually happening to the temperature? The temperature, you can see here, goes from 298 to 268. So that means that it goes down. So we just draw a down arrow right here. Okay, we draw a down arrow. Now, if temperature goes down, we can write little notes to ourselves. If we go down in temperature, then what happens to pressure? Well, pressure and temperature, as you recall, is a direct relationship. So if temperature goes down, that means pressure is going to go down. So if pressure is going to go down, then we can go ahead and start with our problem. We're going to solve for P final, or P2, however you want to call it. Like you could call initial is 1 and final is 2. So P final is 105 psi times, and then we want a ratio. Now that ratio can be either 298 over 268, or it can be 268 over 298. Well, we want to look back and see, okay, well, we want our pressure to go down. So look at these two and figure out which one of these would make the pressure go down if we multiplied it by. All right, if you said this one, you were right. So the 268 is what we want to use to do this problem. We want to use that ratio. So to do this, we're going to go ahead and we're going to plug in the 268 over 298. Now those are both Kelvin. We don't really have to put the units there because they cancel. Now when you multiply and you divide, you get your answer here, and that answer is going to be in the units of psi. So that final answer you get here is going to be 94.4. Now that 94.4, first off, that's 3 sig figs, because we have 3 sig figs here, 3 here, 3 here, so we want 3 sig figs in our final answer. And you want to look back at your answer and think, does it make sense? Our initial pressure was 105. We want our pressure to decrease, and it ends at 94.4. So did it decrease? It sure did, so we know that we did something right. Okay, for number 3, I want you to try this on your own. Hit pause, and then come back and see the final answer. Okay, hopefully you hit pause, and so now you're coming back to this after you've already completed it. Just looking at a few things that you might have missed when you did this the first time around. I'd like us to look at our different pressures and temperatures that are given to us. For instance, did you notice up here that it says it's going to end at standard pressure? Standard pressure, or excuse me, start at standard pressure. Standard pressure, of course, as we learned, is 1 atmosphere, or 760 mmHg, 760 torr, 1 to 1.3 kilopascals, etc. I chose atmospheres, but when you choose atmospheres, make sure that you make it 1.0 and not just 1. Also, we notice that the volume goes down. Now, when the volume goes down, we want to remember that if the volume goes down, then the pressure goes up because it's an inverse relationship. So therefore, our pressure is going to go up. If the pressure is going to go up, then that means that we want to use this version of the ratio. We want to have 250 on top, 150 on the bottom. So therefore, 1 times 250 over 150 gives us a larger number, because we said again that our pressure wants to increase. And our final answer here is 1.7 atms. And does it make sense? Yes, because our pressure went up, so we did this one right. All right, and on to our next slide. For this one here, again, I would like you to try this on your own. This is number 4, and then I want you to come back and just check your answer. Okay, so hopefully you paused it and you've gotten to this point. Now, you might be asking where some of these numbers came from. Standard conditions of temperature and pressure is where we got these numbers here for temperature and pressure. The pressure goes up and it's inverse to volume, so that goes down. Temperature goes down, so it's inverse to volume, so that also goes down. Now, it's not always going to work out that way. Sometimes maybe pressure will make it go up and temperature will make it go down. It doesn't really matter because you still do the problem the same way. Where we're solving for V final, so we take V initial and we multiply it by, in this case, 2 ratios. The first ratio is going to be from the pressure. Now, the pressure makes the volume go down, and since the pressure makes the volume go down, we want to use the ratio that's going to make that go down. So we're going to use the one that has the smaller number here on top. Now, the volume for the temperature is going to be affected. It's also going to go down when we look at the temperature. So again, we want to have the smaller number on top and the bigger number on the bottom. So our final answer, 220 centimeters cubed. For this one here, once again, I would like you to go ahead and try this on your own. And then, so hit pause, try it on your own, and come back and check your answers. Okay, to finish this one up, if we look at these numbers here, the pressure would go up according to the volume, whereas the pressure would go down according to the amount. So what I have here drawn is I drew 2 boxes. One is that the volume is going to make the pressure go up, and one is that the amount is going to make the pressure go down. So now we need to solve for this by plugging in those values. We want the volume to cause the pressure to go up. So if we want the volume to cause the pressure to go up, then we need the bigger number on top and the smaller number on the bottom. We want the amount to make the pressure go down. To make it go down, we need the smaller number on top and the bigger number on the bottom. And so our final answer is 9.2 psi. Now, this one here is from the worksheet that we worked on in class on Thursday, October 17th. And go ahead and try this and check your answer when you're done. Okay, hopefully you paused and you did your work, and now you're able to check your work. And your answer here is 340 milliliters. Remember that you have the temperature decreasing, which if this is a direct relationship, that causes the volume to decrease. So we use the ratio that's going to cause our volume to decrease. So we put the smaller number on top, bigger number on the bottom, and with sig figs, it's going to be 2 sig figs in our final answer, so it's 340. If you're still having trouble with gas laws, I highly suggest you go back and review this video, and also review your packet and your worksheet, and then also come in and see your teacher for some extra help. Good luck on your test on Monday.